Welcome to the chemistry lesson on AL short notes. Let's begin with chapter 1, Atomic Structure. Today we are going to cover the topics the atomic theory and cathode rays. Chemistry is the study of the properties and behavior of matter. Anything that has mass and occupies space is called matter. Matter is the physical material of the universe. Everything in the world is formed from only about 100 elements. So far, 118 elements have been discovered. The heavier atoms are not found naturally, and they are short-lived. The atomic theory of matter. The earliest philosophers speculated from what the world is made. Empedocles believed that all things are made up of earth, fire, air, and water. The Hindus too believed that the world and space are made up of earth, fire, air, and water. Democritus and other Greek philosophers stated that the world is made up of tiny, invisible, indivisible particles. They named these particles as atoms, which means indivisible or uncuttable. Later, Plato and Aristotle stated that there can be no indivisible particles, and when the Aristotelian philosophy dominated the Western culture, the atomic view of matter faded for many centuries. In 1808, an English scientist, John Dalton, formulated a precise definition of atoms, which is called the indivisible building blocks of matter. Dalton's atomic model is also called the golf ball model. Dalton's atomic theory. There are 4 postulates in the Dalton's atomic theory. Elements are made out of extremely small, indivisible particles called atoms. All atoms of a given element are identical in mass and size, but the atoms of one element are different from the atoms of all other elements. Atoms of one element cannot be changed into atoms of a different element by chemical reactions. Atoms are neither created nor destroyed in chemical reactions. Compounds are formed by union of 2 or more atoms of different elements in a simple numerical ratio. In 1891, Johnston G. Stoney named the fundamental unit that carries electricity as electron, but he did not have any experimental evidence to prove that the electron is existing. During the mid-1800s, scientists began to study about the electrical discharge. They used the cathode ray tube for this purpose. Cathode ray tube is a glass tube which is pumped and almost empty of air. This tube was invented by a British chemist and physicist, Sir William Crookes. Therefore, this tube is also called the Crookes tube. Crookes experiment. 2 electrodes were connected to a high voltage source. The negatively charged plate, which was heated, was called the cathode. This cathode produced a stream of invisible radiation. These rays were not to be seen, but their presence were detected because they caused gases at low pressure to glow, which made other substances to give off light. The radiation that emitted from the cathode was called cathode rays. Later, it was known that these rays could be deflected by a magnetic field. They carried a negative electrical charge. Some scientists thought that these rays were waves. Other scientists thought these rays were particles. J.J. Thomson's experiment. J.J. Thomson used a cathode ray tube consisting an anode. There was a hole in the center of this anode. The observation was cathode rays are the same regardless of the gas in the tube or the cathode material. In 1897, he described that cathode rays are streams of negatively charged particles. Through the experimental measures, J.J. Thomson calculated the ratio of the electron's electrical charge to its mass. This value is 1.78 into 10 to the power 8 coulombs per gram. Properties of cathode rays. Cathode rays travel in straight lines. Cathode rays are a beam of particles. They have a mass and possess kinetic energy. When an electric field is applied in the path of cathode rays, they deflect toward the positively charged plate. The nature of the cathode rays does not depend on the material of the cathode or the nature of the gas in the tube. It was found that the charge to mass ratio, it is called the E to M ratio of cathode rays obtained from different gases were exactly the same. In 1899, J.J. Thomson postulated the plum pudding model of the atomic structure. Through the oil drop experiment, in 1909, Robert Millikan measured the charge of an electron as 1.602 into 10 to the power minus 19 coulomb. So, the mass of an electron was calculated in the way that is shown on the screen, and the value comes 9.10 into 10 to the power minus 28 grams. This mass is about 1 of 1837 of a hydrogen atom. The relative charge of an electron is -1. This is the end of today's video. See you next time with the next part of this chapter. Bye bye.